Last time, so this is last time. So let me remind you. So today's we're going to be talking about section 1.3. But today I want to first remind you of what we did last time. So let me just remind you of last time. So there were two important ideas जो हमने last time what we did. So पहली चीज़ थी, there was some big ideas, which was one was we learnt an algorithm. And what was the algorithm about? So the algorithm was algorithm to determine the larger number or the smaller number, it doesn't matter. Determine the same thing, to determine the larger number. Right? So एक हमने ये चीज़ सीखी थी which was how to determine which number is larger, and the algorithm was very simple. If you have a number like 7,800 and maybe 41, and then you have a number like 7,800 and 16, and you want to figure out the larger number, we start from the left. 7 is equal to 7, so we ignore it. उसके बाद फिर 8 is equal to 8, we go to the next significant digit. We always start from the most significant digit, we move right. Then it's the next significant digit. तो आप 8 को compare करते हैं, 8 is equal to 8, so we ignore it. Then since, so the algorithm की जो thought process है, since 4 is larger than 1, this implies 7,841 is larger than 7,816. So that was the algorithm जो हमने last time किया था. And we figured out, so this was the algorithm, and we figured out, so the important thing was algorithm आसान है, we worried about and the correctness. So we worried about the correctness. So the important part was, the sub thing was, we learned the algorithm and then we proved the correctness of the algorithm. Correctness of the algorithm, right? That was an important thing. The second thing we learned was, we at least learned what a convention is. And the convention is, जो हमने approximation की थी, उसमें when we were rounding off to the nearest 10, what we learned was a convention is कि जो anything like अगर आप 15 को approximate कर रहे हैं तो 15 gets approximated to 20 and not 10. That's a convention and not 10. So ये दो चीज़ें हमने जो sort of a bit non-trivial थी, those are the two non-trivial things we learned. So ये कल का हमारा जो lecture था, it was basically about 5-digit numbers. So अगर मैं इसको, last time we talked about, this was chapter 1.1 and 1.2. And this was about 5-digit numbers, and this was about approximations. आज we're just going to briefly talk about factors, multiples and factors, और उसके बाद we'll do something really important जो which is दो बड़े important algorithms हैं which are long multiplication and long division, and those are something that we'll play with. I mean, and we'll really see the significance of those algorithms. So let's just briefly talk about factors and multiples. So this is, now we're going to start with chapter 1.3, which is so आज का हमारा topic है. So इसके बारे में, कल के बारे में आपके कोई questions, anything about yesterday that is confusing? All good? Okay. So chapter 1.3 is about factors and multiples, I think. So factors and multiples. So let's just briefly look at that. Fairly easy topic. लेकिन इसमें there is one interesting thing that I want to, there's one interesting question which is kind of fun to look at. So factors are a way to decompose numbers. So through multiplication. So let's look at an example like 24. So give me examples. 24 is 12 into 2, that's 1. G, anything else? 3 into 8, that's pretty good. Anything else?
6 into 4.
Yeah, 6 into 4. Okay, there we go. Okay, and we can obviously do 1 into 24 if we wanted to, but we could also do 1 into 24 or something. Okay. So all of these things are true, but I mean, when you look at these 4 things, I mean, they are all called factors. So 1, 24, 4, 6, 3, 8, 2, 12, in सबको हम factors कहेंगे of 24. That's just a definition. Okay. But anything interesting that you observe in these factors? Something that is amusing? Something weird. I don't know whether you find it weird or not. I find it weird. Yeah, they look very different. Exactly. They look so different that when you look at something like 4 into 6, how do you think about 3 into 8? Is this factor, like the reason, I mean, you worry about it that 3 8s are 24 and 6 4s are 24, and what do these two numbers have to, what do these two calculations have to do with each other? There seems to be nothing that they seem to have with each other. We'll see later on that they do. Lekin abhi, when we look at prime factorization, so we'll actually see that there is something related in दोनों के बीच में. लेकिन अभी they seem very different calculations that miraculously lead to the same answer. So the miracle should not be sort of lost जब हम यहाँ पे ये चीज़ देख रहे हैं. So let's do let's do some problems just to make sure that we understand factors. Let's try something like question number. So is everybody clear on factors? Koi confusion to nahi? Okay. So let's look at a question. Let's look at something like maybe 16. So 16 is too easy. Let's do what do we do which is kind of fun? Nothing is really fun. So we'll just do 16. Okay. This is a question from the book. So 16 ke factors?
4 times 4.
4 times 4. Others? 8 into 2. Anything else? 1 times 16. I think we are done. I don't see any others. So that's pretty good. Yeah, okay. So we know something about factors, not a problem. We seem to be, so this was question number 2 from the book. This was question number 2. Let's try moving on. और एक और question try करते हैं just to make sure. I mean, it's not very hard, लेकिन just to make sure कि everybody is on the same page with factors. So let's try another question. So here's a question. This is question number 5 from the book. Is 3 a factor? Is 3 or is 7? Is 3 a factor of 21? Is 3 a factor of 21? So the book does something interesting. It tries to divide 21 by 3. That's what you see in the book. Agar aap book ko dekhein, so you see this division, and then it does this division, and this is how it writes. Right, so 0 here, and it's the 21 can be divided. Excuse me. And it says 21 can be divided exactly by 3, so 3 is a factor of 21. So how does it relate to हमारी जो definition थी of factors here? Here we were talking about division. यहाँ पे we were talking about multiplication. So how do the two relate? Right? See, यहाँ पे we were multiplying things to make sure कि 24 के factors क्या हैं. We looked at all the different ways you could multiply numbers and get 24. अब the question arises, somebody asks you a question, is 3 a factor of 21? So you divide 21 by 3 to get 7. Why did you do that?
Find out what you multiply by 3 to get 21.
Yeah, roughly. Yeah, I mean something like that, G.
So there we have product 21. So now we will divide 21 by 3 to know that is 3 the factor of 21. So we can have the second factor for that.
Sure, we actually, so first of all, the question does not want you to find the second factor. It's not the question. So I don't care about the second factor. Okay? Is 3 a factor of 21? The answer is either yes or no. That's it. So you don't care about the second factor. Pehli baat ye hai. The question does not demand it. Lekin what you are saying and what you are saying is roughly exactly the same thing. Remember, 21 divided by 3 equal to 7 means, this is what the meaning is, this is what it means. It means this, that 21 is equal to 3 7s or 7 3s, however you wish to write it. That's what the meaning is. ये बात समझ आ रही है ना? So जब हम डिवाइड करते हैं तो डिवीजन का जब हमने मीनिंग डिफाइन किया था उसका मतलब ये था. So that's how it went, right? So it's like saying 3 7s are 7 plus 7 plus 7. 3 7s, 3 times 7 means 7 plus 7 plus 7. इसी तरह 21 divided by 3 equal to 7 means 21 is equal to 3 multiplied by 7. So if it means that, then we found the factors, so we can check whether 3 is a factor of 21. Is this clear? So that's why you're dividing. And just to make sure that I just wanted to revise this idea that division का मतलब multiplication की terms में हमने define किया था. So that's why we can do that. Okay, another silly question. Well, not a silly question, but a simple question. Let's just do another one, which is question 8, very quickly.
You say that 21 is completely decomposed into factors of 3 into 7. When we are dividing it,
So again, so I'll again थोड़ा सा हमें careful होना पड़ेगा. Completely decomposed is not a terminology which is mathematically so हमें, you have to be very careful with what kind of terminology we use. It has to be very precise. So हमने उसको define नहीं किया हुआ. जब हम उसको define ना करें, उसको use करना would be kind of थोड़ा सा वो उसमें उसकी interpretation हो जाएगी. What does complete decomposition mean? So that's why I would not want to go उस direction में. Question 8. So here's is 8 a common factor of, how would you do this? Is 8 a common factor of is 8 a common factor of 72 and 96? So what does it actually mean?
It means that
Is just the question. I want to understand the question first.
does 8 come when you factor 72 and 96?
So you first have to check whether 8 is a factor of,
72
and then you have to check whether 8 is a factor of 96. And if both are true, then it is true.
is a common factor.
But if it is a factor of 72 and not a factor of 96, then it's true or false. It would be false, right? Okay. So because यहाँ पे भी the answer is either going to be yes or no. That's the only answer that we can give. So is 8 a factor of 72?
Yes.
What is 72 is equal to?
8 times 9.
8 nines, that's true. Is 8 a factor of 96?
Yes.
What?
8 times 12.
Shabash. There we go. Okay. So the answer is yes. That's it. Okay? It is a factor of, yeah. Okay. Let's move on to multiples, unless we have any questions. Any questions about factors? Should we move on? Okay. So let's quickly move on to multiples. Multiples are again a very, so if we say that 8 is a common factor, so for example, if I say, so this is the same statement, it's a sort of, if 8 is a factor of 72 means, in some sense, that 72 is a multiple of 8. Same thing. The same thing. So these are identically equivalent statements. They're saying that if you multiply 8 by something, you're going to get 72, which is 9. And that says if you divide 72 by 8, you're going to get something which is 9. So that's the same thing. Okay? So multiples and factors, it's just like, I don't know, I can't say the opposite of each other, but they're very closely related to each other. Okay? Multiples and और जहाँ पे भी आप कोई comment देना चाहें, कोई question करना चाहें, feel free to just talk whenever you feel कि I'm not clear या something you disagree with also. There's nothing, please इसमें do not. So let's just to make sure that we understand, let's look at multiples of a nice number like maybe, let's look at multiples of 3. So let's look at multiples of 3. So here's 3, 6, 9, 12, 15, right? 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, 57, 60, yes, 63, 66, 69, 72, and 75, and 7. All these are multiples of 3. 81, 84, 87, 90, 93, 99, 96, 99, 102, 105, 108, 111, 114, 117, is that right? I hope so. 120, 123, I'm going to bore you. 120, G? Oh, okay. 126, 129, 132, 135, 138, 141, 144, 147, 150, 153, and I'm going to tire out. I think this is where I stop, 159. And I could go on, but this is getting to be pretty boring. All these are multiples of 3. So these are some multiples of 3. These are some. And so how many are there multiples of 3? Some multiples of 3. So if somebody asks you to count how many multiples of 3 there are? How many multiples? So factors of 21. Then let's look at factors of 21, right? So factors of 21 are 3 into 7, 1 into 21, and that's it, right? So there are 4 factors. 1, 3, 7, 21. How many multiples of 3? I just counted, there are 4. 1, 2, 3, 4 factors of 21. How many multiples of 3? Count?
Count also?
I just wrote down a few of them. So count the rest, count all of them and tell me how many multiples of 3 are there. But this is not going to stop here, right? There are a lot more. So how many multiples are there?
Unlimited?
And infinite, exactly. There are infinitely many multiples of 3. That's fine. Okay, but now you're noticing something interesting, hopefully. Maybe you're not. But let's look at all multiples of 3. They're kind of cool. And that's a question which is, it is sort of referred to, so this is question 8. I'm talking about question 8 in the book. It's kind of a fun, this was the old question 8 from section 1.3. Now I'm moving on to section 1.4. So this was 1.3. Now we are doing multiples. So this was section 1.4. Okay, so just we moved on to 1.4. I'm sorry I didn't write it down. This was 1.4. So now question 8 or 1.4 is kind of fun. That's kind of something that you, write any number that is a multiple of 3, find the sum of digits of the number, and is the sum a multiple of 3? That's the question. So let's look at some multiple of 3. We wrote down a few multiples of 3. Let's pick an evil looking one. Can you pick an evil looking one which is large? 102? That's a pretty nice, decent one. Let's pick an eviler one, somewhere over here. 159. Add 1 plus 5, 6 plus 9.
50.
Is 15 divisible by 3?
Yes.
Okay, let's try another one. Randomly. Pick it even to 1 or 2, the one that you picked. 1 plus 0?
1.
Plus 2?
3.
Divisible by 3?
Yes.
Pick another one. 1 plus 4? 5. 5 plus 7? 12. 12 divisible by 3?
Yes.
Is that magic? Why is that true? It's not true for any other number. Pick any, let's pick something like, pick a number, a small number that you like, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8. So let's pick 8. Let's look at, is 16 divisible by 8? 6 plus 1? 7. Does 7 divide 8? No, it doesn't. Right? That doesn't work. Right? So what is so special about it? Try another number. You want to try 7? Or 6? Which one do you prefer? 5? 7. Let's try 21. Or even a large number like 210. Divisible by 3? By 7? Yes. 30. 2 plus 1?
3.
3 plus 0?
3.
Is 3 divisible by 7?
No.
No, that doesn't work. What's so special about 3? Is 3 a magical number? Do you see that? And pick a random number. Just give me any large number in hundreds. Pick any.
150.
Pick a 742. Okay? 7 plus 4? 11 plus 2? 13. This will not divide 3. That's another statement that I'm giving. Let's try. 2 3s are 6, 1, 14. 4 3s are 12. And if you don't believe me, you can use a calculator or something and check later on that this is correct by multiplication. If you don't know long division yet, we'll do long division in a second. That's fine. Don't worry about it. But you can check if you want to that 742 is equal to 247 multiplied by 3 plus 1. So it does not divide 3. So we have made a very interesting statement. And the statement is kind of cool. So the statement that we have made is, I'm going to erase this part of the board because I like the multiples over there. And then the statement that we have made is that अभी तक जो हमने एक्सपीरियंस किया वो ये take any 3-digit number, take any 3-digit number if the sum of digits is divisible by 3, is divisible by 3, then the number is divisible by 3. Then the number is divisible by 3, right? जिस हमने देखा है यहाँ पे if the sum of digits is divisible by 3, then the number seems to be divisible. And the number is divisible by 3. And we've seen another thing through, which is another thing, which is different. And this is an and if the number is divisible by 3, then the sum of digits is divisible by 3. Number is divisible, it's a different statement, by 3, then the sum of digits is divisible by 3. So pick a number that is divisible by 3. Like you can check whether 741 is divisible by 3, and you can check it is, if you divide by 3, you're going to get 2 times 3 is 6, 14, 4 times 3 is 12, 21, 7, so it's going to be divisible by 3. But this, and the way I know it is divisible by 3 is, I know that the sum of digits is divisible by 3 is because the number is divisible by 3. So 7 plus 4 is 11, 11 plus 1 is 12, 12 divides 3. That's the content of this part of the theorem. So there are 2 parts of this theorem, that's what we have seen up till now. Okay? Now the question is, what's the question?
Why?
Yeah, why is the question? That's the only interesting question. We have observed something interesting, but now we have to worry about why. So you have to worry about why. Okay? And let me give you a hint. I'm not going to give you an answer, but I'm going to give you a hint. So should we pick 741? That looks like a decent enough number. Let's pick 741, and I'll give you a hint. Okay? That's for you to muse about. It's not a part of the course, but it's kind of fun to think about these things because the whys are what makes mathematics interesting. So let's look at 741. This is just equal to place value, our old friend, 100 sevens plus 10 fours plus 1 1, right? Old friends. Okay, let's rewrite them. Now note, I can rewrite this as 99 sevens plus 9 fours plus 7 plus 4 plus 1. Any problems with that? I have 100 sevens. 99 sevens go here, 1 7 goes here. I have 100 sevens. There were 10 fours, 9 fours go here, 1 4 goes over here. There was just 1 1, 1 1 goes over here. So I've done nothing illegal yet. Okay, I'm not going to do anything illegal. Now, note 7 plus 4 plus 1 is divisible by 3. 7 plus 4, 1, 11, 11 plus 1, 12, that's divisible by 3. Is this divisible by 3?
Yes.
Yes, it is divisible by 3, right? Is this divisible by 3? Why is it divisible by 3? Because of the 99 is divisible by 3. This is divisible by 3 because 9 is divisible by 3. So these 2 numbers are divisible by 3. This is divisible by 3. So if you have 3 things, 1, 2, 3, so you have this. So you have a square plus a triangle plus a circle. So now you want to divide it into 3 portions. This you can divide exactly in 3 portions. This you can divide exactly in 3 portions. This you can divide exactly in 3 portions, which means you can divide the entire thing in 3 portions. That's the proof, if you will, of this statement. Now you have to think about it. Okay, does it apply to every number? So my suggestion to you is pick your favorite number, pick another number.
815.
815, write it down on your book. 815? Pick 817 because 8 plus 1 is 9, 9 plus, 816 because 8 plus 1 is 9, 9 plus 6 is 15. 816, okay? Go home and try playing the same trick and you will see you can break up 816 into 3 kinds of numbers. Each one of the numbers is going to be divisible by 3. That means that 816 is divisible by 3. And the reason, you see, this number will always be divisible by 3. Why will it be always divisible by 3? Of the 99. You'll always get a 99. You don't care about this number. This is an important number. You'll always get a 9 here. And that is what will make this part divisible. So the only part that is in question is this 7 plus 4 plus 1, which will change. Aapke case mein it will become 8 plus 1 plus 6, right? And 8 plus 1 plus 6 will turn out to be divisible by 3, hence your entire number will be divisible by 3. And if it were 8 plus 1 plus 5, that number is not going to be divisible by 3 and it will ruin the divisibility of the entire thing. Okay, that's what you want to think about. Okay, anyway, that was kind of fun to discuss and talk about. So what we've learned is, first of all, there's no magic. There's a theorem and we can prove a theorem. But it looks, and this is 9 which is also divisible by 9, so the divisibility will also work for, so depending on okay, whether this number is divisible by 9 or not. So if you tried 741, you can say it is not divisible by 9 because 7 plus 4 is 11, 11 plus 1 is 12, and 12 is not divisible by 9. The same argument applies for 3 and 9 because of 99 and 9. Okay, so we're going to stop here and we are going to continue next time.